So today's lecture is on anonymity. Last lecture, if you recall, we talked about scalability. Today we'll focus on why privacy is important in Bitcoin or blockchain. So far we've talked about how the blockchain is transparent, but we've not really considered what it means for it to be anonymous, and today we'll talk a little bit about that. So let's get started talking a little bit about anonymity basics, and then we'll talk about what it means to de-anonymize someone, and then we'll look at two kinds of anonymity solutions. One is anonymity through mixing, and the second is anonymity through altcoins. So let's get started with a little bit about anonymity basics. So if you recall, blockchains are not anonymous by default. Why is that? You'd kind of assume that if you have your identity linked to a public key, it should be anonymous, right? Well, the intuition is that blockchain just takes a central database and then distributes that out to everyone. So if you have an organization like Facebook controlling who has access to data, then you pretty much prevent everyone from accessing all the data that's available in the world. Like even Facebook employees would have only certain parts of the data they can access. But with the blockchain, you've taken that central database and said, hey everyone, each of you has a copy of it. Now go for it. You get to see all the information that anyone else in the world has. So that means all of your data is now public by default. Private blockchains kind of make this a little better because you can do something where only the members who are part of the blockchain can see all the data. But even then, everyone who is a member gets to see all the data on the blockchain. So most blockchains are pseudonymous. So that means we use something that's not exactly a real world identity, like your Twitter handle or your Reddit username. And pseudonyms may or may not be linked to your real identity. Like nothing's stopping you from putting in a false email in Twitter and then creating a false account. So your Twitter account is not necessarily your real world identity. But you can have it linked if you want to. So linking in the context of anonymity is how easily can you associate this real world person with their pseudonym. And this is called de-anonymization. In Bitcoin, your identity is basically your address. Just like in Twitter, your identity is your Twitter handle. So in Bitcoin, you basically have this privacy guarantee or some amount of anonymity if every time you spend a transaction, you create a new address. Or every time you receive a transaction, you create a new address. If you try to do that every time you spend a transaction, you run into this issue of like, oh, I don't have funding, so now I have to send money from my previous account to my next account. So that guarantees some very basic threshold of anonymity. But in Ethereum, you can't even do that because if you recall, Ethereum is an account-based model and your transactions are not exactly like UTXOs where they're independent of each other. It's just like a balance of how much you have in your account. So you're kind of forced to keep everything linked to this single account. So one thing about anonymity is that it's not completely like a yes or no scale. It's more like a gradual scale. And you have this concept of a degree of anonymity, or how difficult or easy it is to associate your pseudonym with your real world identity. Like how easy is it to associate your Bitcoin address to who you are as a person, or your passport, or like you. So a high enough degree of anonymity means you have privacy. But why is privacy important? We talked about, if you recall, Nadir talked about in the enterprise lecture a little bit about regulations. So you would kind of assume that if you give people anonymity, it gives them more bounds to act in an illegal manner. But privacy is still important, just like you don't want NSA eavesdropping on your conversation with your mom over the phone. So we'll look at a couple of examples as to why privacy is important. In this lecture, we'll talk a little bit about how we break all the regulations that Nadir built up in the enterprise lecture. So, is anonymity only for drugs? Well, let's look at a few scenarios in a world which is completely blockchain based. Maybe that's like a few hundred years down from today, but let's take a look at it. So if you go make a purchase at Walgreens, your cashier looks up at your blockchain.info account and sees, hey, this address sent me this much money. But now your cashier knows what your Bitcoin address is. So they can basically look at your salary, all the funds that you've ever received, or all the funds that you're ever going to send in the future. Do you want your Walgreens cashier looking at that? Probably not. And now, if you maybe spent some money at the site called Bob's Burgers, which is actually the world's largest porn site, now your Walgreens cashier knows all your dirty little habits. Another example is if your cashier now knows all the money that you have in your account, and they see, hey, you got a transaction for 60 million, which you probably inherited from your parent or something, and they decide, okay, I want some money, let me kidnap this person's mom or sister or someone, and then blackmail you, and they know exactly how much money you have, so they know exactly how much you can pay. So, hey, pay me 60 million, if not, I'm not releasing this person. Another example is, so you're at a restaurant with your friend, and they refuse to accept multiple credit cards. So you're like, okay, I'll front the money, and my friend will pay me later, or earlier. So now, you go to Bob's Burgers, and your friend pays you money ahead of time, so that you can pay at the cashier. Except, your friend has been buying drugs from the illegal market, so now, the cashier refuses to accept your money, which your friend paid you, because it is illegal and it contains some amount of taint, or like they don't want to get associated with any of that dirty funds. And this basically breaks this idea of fungibility. Fungibility is this concept that every unit of a currency must be of equal value. So $1 should be $1. Like you can't have. Maybe you've experienced this, but sometimes if you give someone a slightly torn $1 bill, they refuse to accept it. Like they want a pristine, like perfectly nice printed $1 note. They don't want any kind of like tampered $1 bill. So this kind of gets at the same point. And fungibility is a very important property for a currency. So another example is if you're running a business on blockchain. If you have your own startup called BitBlock-BaseCoinPay.cash, and you want to look at what your competitor is doing, and you decide, okay, I'm going to buy some of their goods just so I know what standard it's at, so I can make my goods be the same standard, the same level. So you go to them and you buy something, except you forget to use your personal credit card and you use your business credit card. Except now your competitor has access to, knows what your public key is of your business, and then they can look at how much revenue you have, how much, what your business strategies are, who your customers are, and lots of other data which you don't necessarily want. You basically lost your whole competitor advantage. And why? Because Bitcoin has no anonymity. So the conclusion here is that anonymity is a big deal for everyone. You don't just need anonymity to buy drugs from the illegal market. It's something that any user of this platform would desire. And a lack of anonymity means everyone who has ever transacted with you gets to see all the transactions of your past and all the money you'll ever make in the future. And you don't necessarily want that. You might not want people knowing what your salary is. You might not want people knowing all the secret inheritance you're getting. So let's talk a little bit about anonymity and ethics. So we talked a little bit about how anonymity is used for money laundering and drug purchases. You might not necessarily want to build an anonymous solution just because you don't want people doing all these illicit activities. It's like you're building out a platform for people to do more illegal activities, do you want to necessarily do that? But if you recall from the enterprise lecture, we talked about how you have anti-money laundering laws or like KYC, which you perform. So that might just be sufficient instead of if you build an anonymous cryptocurrency and at the end you do passport checks or identity checks, that could be enough of a governance solution. It is quite hard to implement this sense of morality in any kind of technology because it's like, how does your computer know? How does code know what is moral or what is ethical? It's a very hard question to transform into something that's as dumb as code. It's like trying to govern something that's of IQ 500 with something with an IQ of 5. Like if you recall back to the oracles example, when you're feeding in external data, you want some kind of technology that can distinguish between what is the actual truth and what is just being input as false bullshit. And it is quite hard to do that with just code. But one interesting aspect or way you can think about this is, do the positive benefits of implementing anonymity outweigh the costs of implementing it? So one example is Tor. The US government came out with Tor. Why did they do it? Tor is basically the platform that makes it difficult for officials to monitor any kind of web traffic. But the US government decided to create it anyways just because the positive effects of creating it were much higher than the negative issues regarding which come with it. So for example, that enables people to have free speech or like censor-free talks or opinions in oppressive regimes or in very oppressive places. So far we've talked about why anonymity is important. Let's get into a section where we talk about how to de-anonymize someone. So de-anonymization basically means how can you link this pseudonym with a person's real identity? How easy or how hard is it? Something you can do in blockchain is you can use transaction graph analysis. So you can basically cluster all the different volumes of transactions that are going in and coming out. You can look at the frequency of transactions, and just using this technique, you can figure out, based on certain properties, perhaps some big companies or perhaps some like very unique individuals. Other techniques the idea behind clustering is you have two main heuristics. The first is merging of transaction outputs. So say you're going to buy a cup of coffee and that costs you 0.05 Bitcoin. Usually you don't have many people doing this multiple input, single output transaction. Like, can you think of a use case or an example where multiple people put in inputs to get one single output? So I guess a fair assumption you can make there is, if you see multiple inputs and one output, it's highly likely that all those inputs are from the same person. So if Alice, say, decides to buy this coffee with 0.05 Bitcoin, and she sends inputs from two addresses, you can A and A dash, you can kind of link them both together and say they might both just be Alice's identity. Another idea you have is this concept of change addresses. So if Alice decides to buy a cup of coffee or buy anything, she's not going to use all the money on coffee. Like, a coffee is not going to cost her 1 Bitcoin. So she's going to send some change to another address. So if you have two outputs, likely one of them could be a change address. So you try to figure out which of the two is a change address. And if you recall back to the earlier point where I mentioned each person creates a new public key for every set of funds they receive, then if Alice decides to create a new key for the change she receives from coffee, then you can probably guess that if you've not seen that address anywhere before, it's likely to be her change address. So we use both these heuristics to figure out who Alice Alice is and how you can link all these different parts of her identity to one single person. So we talked about the different heuristics. So let's talk a little bit about the several techniques you can use to identify which cluster is who. So one is tagging by transaction. So that means I could go to Coinbase and make a few deposits and make a few withdrawals. I know the amount that I deposited. I know the public address that I deposited from. And now I just wait for it to show up on this cluster. And once I see it, I know all the different addresses associated with Coinbase. And I can kind of figure out which of these circles Coinbase could be. Another more passive approach is by actually just looking at a transaction graph. So back in 2013, Mt. Gox was a huge part of this ecosystem. So they had a large volume of transactions coming in. So Mt. Gox is, volume of transaction shows you how big the circle is. So Mt. Gox is right here, this purple circle. And as you see, it is the biggest circle in the entire ecosystem. So if you knew that property about Mt. Gox, you could make a very accurate guess about which of this circles Mt. Gox was. And then you had Satoshi Dice, which is a gambling site, which took in a lot of frequent input-output transactions of small denominations. So obviously, its volume of volume is small, but the frequency of transactions is large. So you just look for a circle which has a lot of frequency of transactions, and you see it's like right there, tiny circle there, but has a lot of input-output, small denomination money going in and out. And if you know a few interesting properties about different organizations or companies, you can trace them on Bitcoin. So far we've been talking about companies, but can you also identify individuals? Well, one really obvious way is by saying, hey, I will send you some Bitcoin, and then I'll know what your address is. Or, hey, can you send me some Bitcoin? So if you send me Bitcoin, I know what your address is. So transact with them. Another way you'd know their addresses is if they're careless. So if they're publicly posting on Reddit saying, hey, this is my address, please donate some Bitcoin to me, I'm in real need. Or if in one of the earlier lectures, I posted my Bitcoin address and I'm like, hey guys, send me some money on this address, then now you know my identity and you can link that. A third way is you could use a service provider. So companies like Scry, which was previously called Coin Analytics, do this full time. So they use some of the graph analytics techniques we discussed earlier and try to trace individuals based on all these different heuristics. So let's talk about taint analysis. So taint is if you have a person A and person B, what percentage of funds did person A receive from person B is what you refer to as taint. So taint does not necessarily have to be good or bad. It's just this idea of what percentage of funds did you get. So like I might just want to know what percentage of funds I got from Gloria in all my current volume of funds. Not that she's a bad actor, I just want to know. Or I might want to know what percentage of my funds are from illegal activities like people who bought stuff from the drug market or Silk Road or something. So taint analysis can reveal a lot of useful information. One naive way that people try to go about becoming or like unlinking themselves from previous identities is just sending all their money from the current address to a new address. And this is what happened with Silk Road. So Ross Ulbricht, who is the founder of Silk Road, basically ran into this issue where all his funds were directly sent from his Silk Road account to his private account. No mixing, no any sort of intermediate thing. So it's just like this horizontal send. And when he was in court, he said, hey, look at this. Both these addresses are different, so that means they're not part of my identity. But if you do a little bit of taint analysis, you know that all the funds from Silk Road are all the funds in his account, so the taint is 100%, so which means it's definitely his funds. And that's a very naive way of like cleaning up your funds. The proper way of going about cleaning your funds is, say, you have some funds which are dirty, and then you take in some clean funds from someone else and mix it with your existing funds. And as you see here, the taint goes down from 100% to 66% to 33%, and then down all the way to 11%. And now, at 11%, probably Bob's Burgers will accept your funds. So if you unpaint your coins right, it's great. But if you don't, you end up in a situation like Ross Ulbricht, and you get sent to prison, or your funds just don't get accepted by anyone else. Okay, so this is an example of blockchain.info's taint analysis software. So you can use this to figure out how good of a mixer or like a tool you're using to clean up your funds. So you can just send your funds from one address through the mixer to another, and then you can input your receiving address into this mixer. And if this mixer gives you an address that contained your input, that means the mixer was obviously not doing a very good job. Questions on that so far? Okay. So let's take a short 2-minute break, and then let's talk about anonymity through mixing. Sorry, I just need water. And I forgot my water. 2-minute break. Okay, do you guys want to get started again? That wasn't even a 2-minute break, but yeah. So far we talked about how to de-anonymize someone. So what that means is connect their real-world identity with their pseudonym. Let's now talk about how you can give them anonymity. So let's talk about mixers. So mixers are basically these fake shell companies that do a bunch of transactions so that you can obfuscate the path of sending funds. So if you put in an input and these companies do a few transactions with each other, you should not know what input gave you that output. So if you're a criminal or if you're anyone who has a little bit of tainted funds, then you can use a mixer to clean up your money so that other people in the network will start accepting it. So mixing on blockchains uses the same idea as mixers with shell companies. So here are a few goals of mixing. Like, let's talk a little bit about the background before we jump into what it means. So we have a concept of anonymity set in a mixer. So anonymity set is basically the number of other people in the network who are mixing with you. So how easily can your transaction or your coins be distinguished from everyone else's in the network, or everyone else in your anonymity set? So an example of that is if you're mixing with 30 other people, your anonymity set size is 30. So the main goal of mixing is you want to maximize or expand this anonymity set to be as large as possible. You can do this either by incentivizing more people to mix in the first place so you have a large base, or you can do this by conducting multiple rounds of mixing over and over again. So if you started with 30 people and you do another round of mixing, now it becomes 30 square people. And now if you do another round of mixing on top of that, it becomes 30 cube people. So without actually having a large anonymity set, you can just do mixing multiple times. However, real-world constraints and time constraints means you can only do that mixing recursively a certain number of times. The concept is that the larger your anonymity set is, the harder it is to link your pseudonym to your real-world identity. Ideally, you want it to be hard for anyone to link identities, not just people who are outside your anonymity set, because if someone in your anonymity set can link your identity easier than someone outside, then they can just create a lot of identities and be part of your anonymity set to figure out who you are. You don't want that. Additional desirable properties are you want your whole mixing to be done in a trustless manner. So you don't want any kind of counterparty risk because we want to ensure our funds can't get stolen. Another desirable property is you want plausible deniability. So what that means is you don't want everyone in the Bitcoin network to know that you are mixing. Why? Well, because you usually have this assumption that people who mix have dirty coins in the first place. That's the reason they're trying to mix it. Like if I have clean funds, I don't want to mix it because I might end up with dirtier funds later. And if that's the case, that's bad for me, which means I can't spend my funds. So if you have other people with dirty funds mixing their money, then you want some kind of plausible deniability so that people don't know that you're mixing. So there are 4 kinds of mixing. The first is centralized mixing, the second is altcoin exchange mixers, third is decentralized mixing protocols, and finally we have privacy-focused altcoins. So the concept of centralized mixers is you have this kind of slush fund into which you deposit the money, and some randomized amount of time later, you get a cleaned output. And of course, the slush fund takes a little bit of money to do the job of cleaning your funds. Why you wait for a certain random period of time is, if not, you could do this kind of timing attack, where if your money is going into the fund and coming out within, say, a second or so, then you could probably link both the transactions together and say, hey, it happened around the same second, so they might be belonging to the same person and they're just using a mixer. So here is, So one issue with centralized mixers is you have a counterparty risk. So you're trusting this central mixer to send you funds. What if they decide not to send you funds? Then you're kind of screwed. Another thing is you have this risk of logging. So the central party that's doing this mixing for you could just be keeping track of who sent funds where and then whose funds are tainted or not. And sometimes you might even have the government who decides to install some kind of logging software in a central company's mixing service, and then, oops, the government knows all about you. You don't want that. And of course, you have this huge risk of centralization, single point of failure. So if the government hacks into this central mixer, they can again install some kind of logging software. Some examples of central mixers are Mixcoin and Blindcoin. Mixcoin creates some sort of real-world accountability protocol, and Blindcoin does mixing with what's called like blind signatures. So they can't do any sort of logging because they don't know who inputted what transaction. Can I go up? Yeah. So we talked about centralized mixers. Let's talk a little bit about altcoin exchange mixers. The idea here is you send your money in Bitcoin through, say, different altcoins. So I use an exchange and change my Bitcoin to Ethereum, and then change my Ethereum to Dash, and then change my Dash to Monero or ZCASH, and then all the way from ZCASH back to Ethereum. Well, that seems like a pretty solid idea. The pros are your adversary now has to trace all these different blockchains if they need to know your identity or like what your tainted funds were. And using this altcoin mixing, you have better plausible deniability because you could just be a normal user of ZCASH or a normal user of Ethereum. However, some cons are you have some kind of KYC or AML when you change your funds between all these different coins. So every decentralized or every exchange has to do some amount of regulation checks. Also, you run into this issue of what if all these exchanges are colluding and actually keeping track of who sent funds in from where? In that case, you're kind of screwed because now everyone can trace what path you took from which currency to which currency, and you no longer have any kind of anonymity. Like if the US government decides to go up to all these exchanges and impose that on them, there's no way you can prevent that. So that brings us to this idea of decentralized mixing protocols. So the idea here is you remove counterparty risk and fees completely and remove the middleman. So with altcoin mixing, you could lose a lot of money in transaction fees or in exchange fees when you go from one currency to another. In decentralized mixing protocols, you don't want to have any single trusted third party, and you want to reduce this amount of fees that you're losing. So the proposition is, let's create something that overlays on Bitcoin and helps people mix their coins without a central party. Can this be done? Well, one example of this is CoinJoin, which takes n transactions and then does a multi-sig on them and then gives you n outputs. The pros of it is that it's trustless. You don't have any kind of counterparty risk. You don't lose your funds because you're doing a multi-sig. The cons, of course, are to communicate or facilitate this mixing. You need to communicate amongst all the participants who's going to send what input to what output, and that communication has to happen over some channel or some medium. So whatever authority is listening in on those channels can know how your mixing is happening. Also, it's not plausibly deniable. Like if you see a 30-30 input-output transaction on Bitcoin, obviously someone's mixing. Like who sends a 30 input, 30 output transaction, right? Also, it's not denial of service attack resistance. So if someone takes part in your mixing and then somewhere in the middle decides that they don't want to do it all the way, it kind of stalls everyone else's attempt as well. So some pros of decentralized mixing protocols is you no longer have to have this central point of failure or central company which is going to take your funds and leave. Another pro is you have anonymity against the mix facilitator. So because you don't have a central company which is facilitating the mix, you're anonymous from them. But some cons are you always have this possibility of denial of service attacks which can stall your mixing. You also have a trade-off between like plausible deniability and security. So what that means is you have an n of n multi-sig, but that doesn't give you plausible deniability. But if you want security, if you're okay trading off security, then you might be able to get high plausible deniability. We then talk of this idea of fair exchange mixtures. So fair exchange means let's bring back the intermediary, but let's just ensure that it's trustless. So an example of this is Alice pays 1 Bitcoin to the mixer, and in return she gets a voucher. Now, at a later point of time, Alice can give the voucher back to the mixer and redeem her coins. In this way, you kind of make this whole trustless system. Of course, you rely on this assumption that enough volume of transactions have to pass through the mixer at the same time, and the mixer should not be able to tell which inputs map to which outputs. The key takeaways are, the pros are you don't have to trust the intermediary anymore, and you can build in some amount of denial of service attack resistance. The cons are, it's very hard to build any kind of mixer, be it a fair exchange mixer, be it a centralized mixer, be it altcoin mixing. They're all very hard to guarantee privacy. which is why we come to privacy-focused altcoins. So one example of it is Dash, which uses a mixer called CoinJoin, which we talked about a couple of slides ago. The idea here is you have better plausible deniability since everyone in the network is forced to be part of the mixing. So you have a very large anonymity set. Of course, you have some cons which rely on, like, you have to trust the validators or the people who are running the Dash network, and those are called masternodes. And if you don't trust these masternodes, you're not going to trust the mixing they do, and you're going to kind of hope that they're not colluding with each other. But that's very minimal of a con compared to all the others that we saw earlier. And then you come to more advanced privacy-focused altcoins, which use some kind of cryptography. So Monero is an example of such a privacy-focused altcoin, and they're basically a fork of CRYPTONOTE, which is a currency kind of based on Bitcoin. The idea with Monero is you want to provide two important properties. One is unlinkability, and the second is untraceability. So untraceability is basically you want to hide the inputs to transactions. And you do that by using ring signatures. And unlinkability is you want to hide outputs of transactions. And you do that, again, using the same ring signature, but also you create one-time payment addresses. So let's take a closer look at what each of these means. Untraceability means every input has an equal probability of being the chosen input. So for example, if we have, say, person R receiving some money from Alice, Bob, or Carol, right here, Alice, the money could have been with equal probability from Alice or from Bob or from Carol. And that's basically what untraceability means. Unlinkability basically means if one single person is receiving a lot of money from different addresses, you shouldn't be able to say that they all went to the same person. So if Bob is receiving money from Carol and Alice, you don't want to be able to say all that money went just to Bob. So you create a different one-time address every time Bob receives some kind of payment. And that's basically what it means to be unlinkable. Some pros of Monero is that no other coin or any other product in this space has so much of proven cryptography and anonymity that they're using. In fact, Monero uses ring signatures, which are some very age-old concepts in cryptography. They've been used for a long period of time. Other pros are, of course, you have faster block times, but that's not relevant. Some cons are Monero doesn't hide the transaction value. So if you recall, you're hiding the input addresses and you're hiding the output addresses. But what if I send a transaction of, say, 10 million Bitcoin? It's highly unlikely that anyone else in the world has that much money, so which means just based on the value, you can trace down to who the possible people are who could have sent that transaction. Also, we have a decent anonymity set, but the question is, can we do even better? Enter ZCASH. So if you remember back to last lecture, we talked about zero-knowledge proofs a little bit. So zero-knowledge proofs are this idea that you prove to someone you know something without revealing any of the information that you know. So the idea with ZCASH is you reveal nothing about the inputs, the outputs, or the values. And ZCASH uses something called zero-knowledge succinct non-interactive arguments of knowledge, which basically is zero-knowledge proofs, or crypto magic. So the idea with ZCASH is you have a coin, and then you do what's called a minting procedure, which puts it through this crypto magic black box and gives you an output, and you do what's called a port to get some ZCASH back. So it looks a little bit more like this. So a transaction on Bitcoin looks like this. 2 Bitcoins was sent from Alice to Bob. You can see the sender's address, the receiver's address, and the value. Now in ZCASH, instead of an input, you put in a zero-knowledge proof of validity. So what that means is Alice, instead of sending her transaction as an input, sends a proof that she has enough funds in her account and she owns the Bitcoin as an input. And now her output is basically all the parameters that Bob would need to create such a proof at a later point of time. So she takes all the parameters that he's going to need and then encrypts them with Bob's public key, and Bob can now decrypt it at a later period of time when he's doing a transaction with his private key and use that to create another proof of validity. In this way, you don't see any inputs, outputs, or values. ZCASH actually has a zero-knowledge security layer, so if you do want to make transparent transactions, you can go for it, but you can do something even more interesting. You can just hide the input and do transactions which are output transparent. Or you can just hide the output and do transactions that are input transparent. So you can move from layer to layer. You don't have to do completely anonymous transactions as well. And that's something very cool about ZCASH. So here's a little peek behind some of the math that goes behind. ZCASH uses something called homomorphic encryptions or homomorphic hidings. The idea is if we're given an output, it should be hard to find an input, and different inputs should lead to different outputs. So an example of a homomorphic function is, say I'm Alice and I have two values, x and y, such that the sum of them is 7. Now I don't want Bob to know what x and y are. I just want to prove to him that I know such x and y values. So Alice can send a homomorphic function f of x and f of y to Bob. Now Bob, just using f of x and f of y, should be able to calculate f of x plus y. You can't do that with normal math, but using specific homomorphic functions, just given f of x and f of y, you're able to calculate f of x plus y. So Bob can now calculate f of x plus y and then see if that matches f of 7, and if that's so, he's convinced that I know such an x and y pair. Some pros of ZCASH are that it is completely anonymous, so there's no kind of linkability or traceability that anyone can do. And it can be integrated on top of any consensus mechanism. So you can have a zero-knowledge layer on top of Ethereum, you can have a zero-knowledge layer on top of Bitcoin, on top of a proof-of-stake system, on top of a proof-of-work system. It's all completely fine. Some cons are it is super resource intensive. It takes a long amount of time to generate your proofs. It takes like 4 gigabytes of RAM and like 40 seconds of computation on your CPU to generate a proof. And it also requires this semi-trusted one-time setup. Assuming that the people who did the setup didn't collude with each other, everything's okay, but you're still trusting them, and you don't necessarily want to have trust in a trustless system. Another huge con is it assumes security at a network level. And that's a con of every single privacy-centric altcoin or any mixing. It's that you're not hiding your IP address. So when you send packets across the internet, if you're not using Tor or any kind of like IP spoofing software, then you can pretty much track down the person just based on that. No matter what kind of mixing or anonymous stuff they do on top at the Bitcoin level or at the blockchain level, you can track them down just based on the IP address. That breaks all kinds of security. So in conclusion, here's a rough comparison of the different anonymity levels of all the stuff that we talked about. So going from least to most, Bitcoin, centralized mixers, decentralized mixers, altcoins, Dash, Monero, and ZCASH. ZCASH is definitely the most anonymous of all of them. So if you ask a practical question, how would I mix today? Well, probably use some kind of altcoin exchange through, of course, I would use a Tor and VPN because I don't want to get screwed at the network level. But yeah, I'd use some kind of altcoin exchange through maybe Dash or Monero or ZCASH, and then throw away my exchange accounts, emails, and use multiple different exchanges. So not covered in this lecture are Lightning Network, Mimblewimble, and confidential transactions, but those are other anonymity techniques. So that's all for today's lecture. If you have questions, feel free to come up and talk.